Okay. Ask him.
Okay. Damien, so what makes aeroplanes fly?
Besides money.
Besides money, what makes them fly?
Is that the long answer or the short answer?
The long answer. And I mean, we know the normal theory about.
And this is going on YouTube, so no pressure.
Yeah.
Alright, okay. Well, let me start with the short answer and say why it's wrong and then move on to the long answer.
Well, what is wrong?
The Bernoulli's theorem, the idea of a low pressure and a high pressure. We teach that to students because it's the easiest thing to teach them, and they don't often ask you questions afterwards. So. But the truth is that it's got a lot more to do with physics, Newton's laws and all the rest, than it actually has to do with low pressures. Okay,
Sorry, just get the door.
Yeah.
Okay.
Can you help him?
Right, well, we've all read that obviously it's to do with the low pressure on top of the wing and a high pressure underneath the wing. And the way they come to that theory is they say, well, I've got this wing which has got a flat bottom and a curve over the top. And assuming this wing is now moving through the air, I've got two particles of air. The one is being forced to go over the wing, the one's being forced to go underneath the wing. And the idea is they both meet up at the back at the same time, which means that the top particle had further to travel than the bottom particle. Whenever there's an acceleration of air, there's a lowering of pressure, hence the low pressure above the wing and the high pressure underneath the wing. And the theory is the wing actually sucks itself up. That holds true for the Cessna typical straight and level flight. Unfortunately, it falls apart horribly when you start looking at high-speed aero-D and inverted flight and fully symmetrical airfoils and stuff like that. So, what actually happens? It's the old law that for every action there's an equal and opposite reaction. What's actually happening is we're taking air, which is sitting still minding its own business, and we accelerate it downwards. In the process of accelerating it downwards, we actually accelerate ourselves upwards. That's actually where the lift comes from, as simple as that. Air is pretty much like a liquid. It has viscosity. It wants to stick to things. The easiest way to demonstrate this is if you've got some flowing water coming out of a tap and you hold, let's say, a glass alongside the water flowing down, the water will actually flow past the glass and actually tuck itself underneath. You actually get that sort of scenario where the flow of water will do that. So the water actually wants to stick to surfaces. Same thing with air. It has viscosity. It wants to stick to a surface. So what happens now is, as you've got this wing flying along with its curved surface, air particles are actually sticking, potentially, sticking to the surface and actually following the downward pattern of the wing. And actually, as they leave the back of the wing, you've actually got this downflow of air. So whenever you see an airplane flying in a wind tunnel that's got smoke, you can very clearly see that the smoke leaving the back of the wing is actually rushing down quite quickly.
Sorry, I'm not bored. I mean, yeah, carry on.
Okay, so yeah, it's all about the downward acceleration of air. As much as a lot of people seem to think this is not true because if you do the calculation, you have to you have to accelerate tons of air downwards at once to lift your aeroplane up. But the truth is that that's exactly what's happening. It's not just the layer of air directly over the wing. It's a good anything up to about 9 feet, even 3 or 4 meters of air above the wing actually gets accelerated downwards. Because what's happening is your first layer is being accelerated downwards. As it's getting pulled down, the rest of the air that's actually up here is actually coming in to meet its place. So you've actually got air from up here on its way down as well. So you've got a whole massive flow of air from up here heading down. And that's basically it.
That also explains then why airplanes have a service ceiling then, because the air gets thinner at the top, so we don't have that much air to generate lift anymore.
You can look at it that way. It's a bit more complicated. We will eventually get to a stage where we can't accelerate air anymore. There isn't enough air to accelerate. The service ceiling is also based on how much power the aeroplane has. With enough thrust, we can actually even stop using the wing and just go up like a rocket. But if we don't have enough thrust,
So airplanes fly with a propeller.
yeah, very much so. Good afternoon.
Brenda makes tea.
Hey, how's it going?